Black hole and neutron star collisions cited twice in 10 days by Pallab Ghosh, Science correspondent, Tuesday, June 29th, 2021, 5 o'clock p.m. So what is this? Scientists have detected two collisions between a neutron star and a black hole in the place of 10 days. I'm sorry, in the space of 10 days. Researchers depicted that such collisions would occur, but did not know how often. The observations could mean that some ideas of how stars and galaxies form may need to be revised. Professor Vivian Raymond from Cardiff University told BBC News that the surprising results were fantastic. We have to go back to the drawing board and rewrite our theory, he said effusively. We have learned a bit of lesson again. When we assume something, we tend to be proved wrong after a while. Let's read that again. We have learned a bit of lesson again. When we assume something, we tend to be proved wrong after a while. So we have to keep our minds open and see what the universe is telling us. Black holes are astronomical objects that have such strong gravity, not even light can escape. Neutron stars are dead stars that are incredibly dense. A teaspoon of material from a neutron star is estimated to weigh around 4 billion tons. So I'm like this. It's got to be tons. It's got to be tons. It's got to be tons, yeah. Both objects are cosmological monsters, but black holes are considerably more massive than neutron stars. In the first collision, which was detected on the 5th of January 2020, a black hole 6.5 times the mass of our sun crashed into a neutron star that was 1.5 times more massive than our parent star. In the second collision, picked up just 10 days later, a black hole of 10 solar masses merged with a neutron star of 2 solar masses. It says, when objects as massive as these collide, they create ripples in the fabric of space called gravitational waves. And it is these ripples researchers have detected. The researchers looked back at earlier observations with fresh eyes, and many of them are likely to have been similar mismatch collisions. Much of R&D work necessary for the breakthrough was done at Europe's GEO 600 laser interferometer. 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 I gotta dig on that. What is an interferometer? Researchers have detected two black holes colliding as well as two neutron stars, but this is the first time that they have detected a neutron star crashing into a black hole. So apart from completing the set, why does this latest collision matter? It is because, according to current theories and past observations, neutron stars tend to be found with and collide into other neutron stars, and the same should be true of black holes. Let's continue. In fact, there are factors which reduce the chances of the two distinct objects being found together. But the two neutron star black hole collisions published in the Astrophysical Journal Letters may challenge that received wisdom. Let's read it again. But the two neutron star black hole collisions published in the Astrophysical Journal Letters may challenge that received wisdom. What's going on? Instead, it may lean towards other suite or suite of theories, which assume that black holes and neutron stars are indeed found alongside each other. These alternative theories imply that stars and galaxies formed in different ways to the picture painted by standard views of how the cosmos formed. Yes, sir. If you don't get this, this is my new research. I think I got a new love, a new something for me, you know. We need these things. I love cosmology, man, because, you know, cosmology is what it is. So let's go. Where we at? Okay. For example, over billions of years, stars have published many of the building blocks from which larger cosmic structures, such as planets and galaxies, are formed. The production within stars of so-called heavy elements, such as iron, carbon, and oxygen, is related to the proportion of black holes and neutron star pairs in the universe. The force with which stars push out the material inside them when they explode is also related to this proportion of black hole and neutron star pairs. What? So I'm recording. Excuse me, guys, the family. You know, I'm the chief of my tribe, so everybody always need something. You know, I can't even record a video without. Yeah, but you gotta love them, man. Yeah, my young soldiers ready, going to be ready, ready now. They ready now. They ready now. Yeah, they ready. So we let's get this. Let's do this paragraph again because I had somebody come in and interrupt me. All right, excuse me. For example, over billions of years, Stars have produced many of building blocks from which larger cosmic structures, such as planets and galaxies, are formed. The production within stars of so-called heavy elements, such as iron, carbon, and oxygen, is related to the proportion of black holes and neutron star pairs in the universe. The force with which stars push out the material inside them when they explode is also related to this proportion of black hole and neutron star pairs. In conclusion, the new finding suggestions excuse me, the new findings suggestions stars produce fewer heavy elements, push them out with less force than previously thought, which in return has implications for real world observations of the universe. No existing theory can perfectly explain what astronomers see in the night sky, but according to Dr. Raymond, many of the ideas can be tweaked to better fit what we now know. Professor Sheila Rowan of Glasgow University told BBC News that observations have the type and the frequency of collisions of black holes and neutron stars over the past 6 years is creating an ever more detailed picture of the dynamics inside galaxies. An interferometer, how a gravitational wave hunter works. Let's look at this for a minute. Light storage arm, mirror, laser, beam splitter, mirror, light storage arm, photo detector. Hmm. Okay. Gravitational waves alternately stretch and squeeze the space they pass through. Gravitational waves alternately stretch and squeeze the space they pass through. No gravitational waves. Affected by gravitational waves. Okay. Makes sense. All this is giving us a rich picture of stellar evolution. This latest observation is another first for us in our understanding of what is out there in the universe and how it came to be the way it is, she said. The collisions were detected by measuring waves caused by the sudden changes in gravitational forces that occur when two massive celestial bodies collide. These are ripples in the fabric of space itself, just like a stone thrown into a still pond. These so-called gravitational waves travel hundreds of millions of light years across space and were picked up by detectors in Washington State and Louisiana in the United States, and the Virgo detectors in central Italy. Together, they form the Advanced Light Interferometer, Gravitational Wave Observatory Collaboration, ALIGO. Shout out to Aligo, 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 ALIGO. Yeah. By the time you reach us, the ripple of atom item detectors of most future team detect neutron star black holes are also observed by telescopes, both in space and on Earth. The power of new the ALIGO by over 1,300 scientists from 18 countries and included researchers from 11 UK universities. So, yeah, but cosmology, yes, it's my thing, it's my new thing. So today I'll tune in. As long as Most High keep me on the planet, I'ma do these daily cosmology information about our situation. Um, yeah, yeah, and I'm also come around with some laws on different things like laws of attraction. I'm gonna get into these things, man. You know, laws of attraction is nothing but uh, you attracting positive situations. The laws of attraction, you know, you know, you know. I'm trying, you know, yeah. I attract only positivity, and when I attract something that ain't right, yeah, I know how to remove myself. Yeah. So, you know, all right. So let's rare black hole and neutron star collision observed by scientists. It's the same one. It's not the same one. No, oh, it's a different one. Yeah, it's a different. Yes, I'm sorry, guys. It's a different article. Yeah. So let's start from the beginning. Rare hole and neutron collision observed by scientists twice in 10 days. All right. So you see what's going on. Shouts to Pixabay for the beautiful photos. Researchers have detected a neutron star and a black hole colliding for the first time ever. They didn't collide just once, but twice over a 10-day period. Scientists have predicted that the collision would eventually take place, but had been no idea how many times it would happen. Typically, black holes only collide with other black holes, while neutron stars only collide with neutron stars. So scientists are having to go back to the drawing board and rewrite their theories. Okay? These are all theories. All writings, most writings are theories. Most writings are. So, but let's dig on this black hole. Dig on this black hole. So yeah, news for black hole. Black hole devouring neutron star sends gravitational scream all the way to Earth. Let's get that again. Black hole devouring neutron star sends gravitational scream all the way to Earth. Pac-Man. What's this? Black hole spotted eating neutron stars for the first time. Let's get some visuals, right? Ancestors, please protect me. Please keep an eye on me. Uh, keep negative situations away from me. Man, black holes spot eating stars by force, shall force, respect. Wednesday, 2021 o'clock this morning. And what could be considered a sexual version of man? Scientists have detected black holes gobbling up neutron stars, marking observation of collisions between the two most extreme objects in the universe for the first time, for the very first time. I love cosmology, man. I love it. And the hefty feast occurring 1 billion years ago. Yeah, man. Like this impression, new star and black merging. Mission go within a 10-day time frame of over 1,000 international scientists spotted the rare cosmic event twice using the Laser Interferometer Gravitational Wave Observatory in the United States. The Virgo Gravitational Wave Observatory in Italy. They published their findings, originally documented in January 2020 on Tuesday in the Astrophysical Journal Letters. Astrophysical Journal Letters. Love it. You know, I just I found a new love, man. I like cosmology. Like, you know, just rock with me. Let's learn. Let's do some learning. Let's learn some cosmology. Let's learn some cosmology. Ain't nothing wrong. Let's learn some cosmology. So, well, I'm gonna go to the journal. Okay, let's see. I'm gonna do this. Create, so it's journal letters. Physical journal letters. There we go. Oh, this is deep too. I love it though, man. This is good exercise for the mind, good exercise for the brain. You know, because worldly things not always so good. So let's check it out. What is this? Astrophysics detect first black hole neutron star merges. Okay. Cosmic hand hitting a wall. Cosmic hand hitting a wall. Missions of remarkable cosmic structure have been measured for the first time using NASA's Chandra X-ray Observatory. The blast wave and debris from an exploded star are seen moving away from the explosion site and colliding. Okay. We got Hubble data confirms galaxies lacking dark matter. Study points to seed black hole produced by dark matter halo collapse. Supermassive black holes, or SMBHs. SMBHs. I'm just laughing. My little brother nickname BHB. My dad gave him that nickname BHB. Yeah, which meant big-headed brother. Yeah, man. I remember life used to be fun. Now, are black holes with masses that are several million to billion times the mass of your sun. Supermass black holes, goodness gracious. Dang. The Milky Way host an SMBH, right, with mass of few million times the solar mass. Hmm. So just read. I'm just reading. I'm surfing the wave and I'm learning that. You know what I mean? I'm surfing the wave in real time, like real time. I'm just as I'm going. You know, it wasn't no homework prep and none of that. I'm just yeah. So work with me. I'm looking at this stuff like okay. Total solar eclipse. Shine a light on the solar wind with help from NASA's ACE mission. Yeah. We got Rosetta Stone. Eruption of the sun could help explain solar explosions. GMRT measures the atomic hydrogen gas mass in galaxies 9 billion years ago. White dwarf stars, debris disk formation delayed. Study reveals diverse magnetic fields and solar type star forming cores. Alright. Reconstructing 3D magnetic typology of own disk solar prominence solar prominence, yeah, solar prominence bubbles, reconstructing 3D magnetic typology of on disk solar prominence bubbles. I don't like getting. I start seeing words like that. I don't even want to. Yeah, nah, it's alright. Some of this stuff I don't even want to get into, man. Let me back up, man. I'm done. Where I'm at now. Okay. See, I also know how far to go. I get into this stuff like, you know what I mean? I be trying to know the basics. That's it. I ain't. Some of this stuff be too deep. The way my mind thinks, I know when to back off. You know, don't be disrespectful. Trust me, I get it. Do not be disrespectful. So, I get it. So, let's read some of the safe stuff. Yeah. Where was we at? Oh, yeah, we looked up. Okay. Black holes. Alright, so let's go ahead. Despite this, Professor Vivian Raymond, shouts to Miss Raven, shouts to Miss Viv, from Cardiff University, described the findings as fantastic. Miss Viv, I was feeling Miss Viv like, I ain't know I was going to say that. Despite this, Miss Viv, shouts to Miss Vivian Raymond from Cardiff University, described the findings as fantastic. She added, "We have learned a bit of a lesson again. When we assume something, we tend to be proved wrong after a while. So we have to keep our minds open and see what the universe is telling us." Just sometimes, man, we don't gotta be aggressive and at somebody's throat all the time. Sometimes we can learn. The first collision took place on January the 5th, 2020, while the second occurred 10 days later. They were detected via ripples that the collisions caused, also known as gravitational waves, BBC News reports. The first crash involved a black hole 6.5 times the mass of our sun and a neutron star that was 1.5 times more massive than our parent star. The second collision occurred between a black hole of 10 solar masses and a neutron star of 2 solar masses. To put into perspective just how massive is, a teaspoon of material from a neutron star is estimated to weigh around 4 billion tons. Tons. Tons? Well, I got 2 ends. Now, imagine trying to put that in your morning cup of coffee. Shouts to Miss Vivian. Shouts to Miss Viv. And Pixabay Pictures. No disrespect. Let me get a page going here. Did I go? I'm moving too fast. I know you guys don't want to be like too slow. I know I got a fair use in here. What is that? I passed it? I must have passed it again. Let me get this up real quick. Because I don't usually do this. I do this on my own time. I mean, you know what I mean. Like, I don't know. It's this, this thing. I gotta get used to this stuff. But yeah, one of my jackets that I designed, indigenous apparel. So, understand? That's one of many. I don't see it. I don't see it. Did I go past it? That's a bunch of pictures. Ain't nothing serious. Y'all crazy. I ain't got nothing to hide, man. You know what? Let me just fall back. A little bit of uh, uh, brain exercise. Uh, I have different ways of brain exercise, and it's not always the screen.
Fair use. Fair use.
There's my fair use. Alright, so let's go. Shows the PA images. As to why the collisions are such a big deal, it's down to the fact it could demonstrate that black holes and neutron stars can be found close to one another. Hmm. If this is the case, it could also imply that stars and galaxies are formed in different ways than initially thought. When stars explode, the materials inside them are pushed out at force, something which is linked to the proportion of black holes and neutron stars. In the wake of the new findings, it's now thought that stars could push out fewer heavy elements such as irons, carbon, and oxygen than first believed, and with less force. As a result, this has implications for real world observations of the universe. BBC News writes. Shouts Naima Shackleton. Shouts Naima. So I was looking around. So yeah, we have this article by Unilad. Focus. Use your lens. Use your lens. Use your vibrations. Use your frequency. Use your energy. Only you know about your frequency.